Hello, hello. Welcome to the Thoughtful Edge podcast. And today we're going to talk about the tech side of things and distributed databases in particular. I have Nabil Nawaz with me today, who is a senior database technology leader with 26 years of experience in technical pre-sales, database architecture and design, and in IT consultancy as well. And before we start, I have a personal question to you, Nabil. Could you please tell us about your career journey and your current role at PinCap, your current company?
Yes, sure. Thank you, Demetrio, for having me on the show. Very excited to be able to speak with you and share my story with the viewers. So, yes, my name is Nabil Nawaz. I started my IT journey back in 1997. I have a degree in computer science, and I started as an Oracle DBA. I thought Oracle would be a great field to get into, a very hot market for the database market back then in the late 90s. There was quite a few projects that were going on about Y2K. So a lot of databases and applications were being overhauled to be able to handle changing to the year 2000. So eventually, after many years, I started doing consulting. I got into architecture, designing highly available systems with Oracle. I even got involved with working with Oracle's flagship technology, Exadata, on premises and in the cloud. I even had an opportunity to help write a book on Exadata with a team of people. It was a good opportunity to be able to be part of that. And then in the last, I would say, a few years, I've been involved with a different technology, distributed SQL databases. So since I started working with a single store, a MySQL compatible database over a year ago, and then recently, in the past, I would say 9 months or so, I joined PingCap, working here as a pre-sales engineer currently, supporting the pre-sales technology of TiDB, Titanium Database. So that's just a little bit about my high-level background. And also, a big part of my job, just give you a brief description, is to be able to speak about our technology and to share this at informational events such as this one that we're doing now and meetups, presentations that we do at meetup groups and around the world. In fact, I will be going to the UK in a few weeks to be able to speak at a meetup in London to talk about our database technology with users over in Europe. So
Amazing, amazing. Yeah, you have such an impressive story and such a long career journey. And I believe you've seen a lot during those years, especially the industry evolution. And I can imagine that during the last decades, a lot of things changed. And could you please tell us, as you witnessed this transformation firsthand, how it was evolving and how it was changing and how it was adapting to the new realities and requirements of the business?
absolutely. So a lot has changed. It's been almost 30 years since I've been in the IT industry, and many things have changed in terms of database volumes. A lot databases back then were in the megabytes or small gigabytes. Maybe having a 50 gigabyte database was big. Nowadays, we're talking
Right,
about terabytes and petabytes
right, right.
managing that. So, and people were accessing database platforms through VT terminals and micro workstations. And now we're able to, in the palm of our hand, just use a phone and to be able to manage the database platform. So a lot has changed. So many systems, especially database technology, started off by being monolithic, meaning that they were standalone on a single server. You have your compute, your memory, and storage all on that platform, right? And Oracle has been around for a very long time. I started my career using their technology, and that was the traditional architecture model. And it's very similar with the others as well, such as SQL Server and DB2. So these systems have been around for a very long time. And being on this monolithic type of a platform led to many issues in terms of manageability, such as having limited to no high availability, right? Just being on a server, if something goes down, like a disk, for example, or we have a problem with the CPU, the whole system goes down, right? So you have limited you have problems with high availability, limited failover and business continuity options, right? So if you're, which means if you want to have business continuity, usually you'll have a replica or a failover system. But back then, in the 90s, when people had systems, they usually just had a primary system and made sure they had a good backup policy. And to be able to restore that quickly was their business continuity. So that was an issue. And but as time went on, people started establishing those things. And then data volume, as I mentioned, is a huge problem, right? People did not expect the amount of volume to grow, being managed by the applications and running within the database platform to grow so fast. I was working in the telecom industry, and you can imagine being able to manage that type of data for users. Is, the databases were growing quite a bit, and we frequently, that was our number one on-call issue, is to be able to, how do we handle the growth? We're always working with our storage admins and Unix administrators to be able to add storage.
That's
But how do
that's an interesting problem to have on the one hand.
Yes, definitely. And then being able to handle these types of issues with data volumes, people were looking for how can we have specialized databases just to handle our transactional hot data, and how can we handle data that is meant more for offline or reporting. It doesn't have to be real time, but maybe we'll do some analytical reporting at the end of the week or at the end of the month, right? So people started building specialized transactional and analytical databases, right? Because this was a problem that the with the data volumes, that they wanted to be able to develop these two different types of systems. And then furthermore, people would tune their databases to be able to handle just a transactional or an analytical workload, right? You would have your data warehouse and you'd pull the data daily or every week from a ETL batch job, or every month to pull the data over and then run your reports. And then I would say after about 10 to 15 years, maybe in the 2000s, NoSQL databases started getting very popular, where people wanted to be able to store maybe web data on the internet, maybe just key value data, right? Just simple bits of information for people logging into a database on a website, and just storing information such as maybe their IP address and what they clicked on. You just want to store clicks. Okay, a good use case for that would be a NoSQL type database such as Couchbase or MongoDB. And then finally, let's fast forward a little bit to 2012. The inception and kind of the birth of the distributed database technology started with Spanner, which was later adopted by Google. So in 2012, they had a really nice paper they shared with the world, very popular, and it's really the birth of the modern distributed SQL database.
Interesting. And
Yep,
the distributed databases are getting traction for sure until nowadays. And a lot of companies looking at this direction. And you already mentioned like a lot of reasons that they are more reliable, they may be more providing more performance. And what are those other specific that comes to your mind when you think about the need of having more of the distributed base on the market, distributed databases on the market?
absolutely. So there's many, many reasons. So let's go back to what I talked about with Oracle, and not to pick on Oracle or any other older legacy database technology. But if you want a database that can do pretty much almost anything that you need in terms of performance and functionality, these legacy database platforms have been around many, many years, 20, 30, 40 years. They've been able to refine their product, and they're getting closer to perfection all the time, right? And they pretty much provide you anything that you can imagine, any use case that you can imagine under the sun, right? And there is one downside for that. It's the total cost of ownership. Usually, people are looking for an alternative. People and
Right.
companies are looking for an alternative that they necessarily don't need to pay. They don't want to pay an arm and a leg and pay such a high competitive, high cost to be able to manage or getting licensed from an Oracle database. The other problem with that is some people um, are locked into applications, right? Their application may only run with Oracle, and that is a problem. And
Yeah, especially when
companies
it's
that
a
stay on.
when it's a legacy application and they have a lot of code already using some of the specific of that current implementation. Yeah, that's a problem for sure.
Exactly, exactly. So I would say for modern distributed SQL databases, if somebody is looking for an alternative, there's many reasons why someone would choose that, right? Rather than an older legacy database platform, which I gave examples for, such as overall total cost of ownership. Usually, a database like TiDB, for example, will be at least a third of the cost compared to other legacy databases. And this, of course, depends on the sizing and the data volume that is required to support that. But usually it will be a lot more cost effective. And then in terms of security, we can provide, if not the same level of security, if not better, than as compared to a legacy database platform. And something that's really cool now, and that's common, more of a common trend in today's world, is companies are now adopting open source technology, open source applications, open source databases to run their business critical systems. That's really something that we'll talk more about in a moment. But and then also another thing is vendor lock-in. Sometimes we just talked about you might be locked in, you might be logged into
Right.
the database or the application. You really have no choice but to stay with where you're at today because it may take you a decade to get off of that, and it may not be worth the price. But
Yeah.
you can avoid vendor lock-in if you can look at a distributed SQL database like TiDB. And other things to consider are the performance. In many cases, are much better that you can get out of the box with a distributed
Hmm.
database platform to be able to run transactional data warehouse workloads. And scalability is very key. That's a problem a lot of monolithic systems have. Imagine just being able to scale your database platform online without downtimes. You don't have to worry about taking down the application or the database. The users will be happy, and you've added additional CPU and memory and and storage right away. It's available, and
Right. Oh,
having
it sounds like additional advantages for the engineers and developers that are working on those systems. So less hassle in the during the updates, during some of the deliveries or the
absolutely.
bug fixes or anything. What are other challenges might be might go away for the engineers with the embracing of those approaches?
So a lot of engineers, they spend time as the data volume grows, they're having to manage that data. And one way to manage it is to partition or shard that data into smaller pieces. So when you have a query run, instead of doing a full scan against thousands or millions or billions of rows of data, right, being able to have that sharded into smaller pieces, and maybe you only need the data for a specific month or a specific week, and having that data divided into these small sharded categories makes it much easier. And that work is a challenge for application developers where they actually have to have a
Right.
sharding methodology to be able to handle the scaling database, right? So doing that
And then tuning on the fly,
yes,
retuning when there are much more data coming and all that. Yeah.
exactly, it's a huge challenge. So as I mentioned, a lot of the developers nowadays, they have a very strong relationship with open source community, right? Using websites like GitHub to be able to online repositories for code. They really look to open source technology, applications, and databases to be able to run their business critical applications. In fact, we just spoke with a customer where we had an internal meeting. It's a Fortune 100 company that we all use without mentioning the name. They said clearly, multi-billion-dollar corporation. They said clearly and openly in our internal customer forum that we want to look at open source technology for our next database platform. you know
Mm,
and and one of the big reasons is they don't want to be spending so much just to run their modern applications. They're looking for something that's cost competitive and can give them the high level of performance, security, scalability, high availability, all of these things in this new distributed database technology.
Interesting. Yeah, yeah. Now this is definitely a trend, and a lot of companies are now like struggling with this kind of problem of storing a lot of data and querying that. And like I can say the same for my company as well. We always in search how we can optimize, how we can store less data, how can we be more efficient. And if we are talking about someone who wants to start working with the distributed databases,
Very, very
where would be a good place starting point?
well. I don't want to say anything about our competitors in a wrong way, but since I work for PingCap and we're promoting TiDB Titanium database, I would say it's easily go online to GitHub and just download it to get started, or you could easily, if you want a cluster pretty much immediately within a few seconds, you can go on to our website, pingcap.com, and provision a serverless to your cloud database platform. And within a few seconds, you'll have something that's free. The developers can go ahead and run the database platform and just start creating their schema and start loading data and start using it right away. I would say that's probably the easiest way to get started. And we have a really nice open source community, an open source. We also have a community Slack channel where we would be able to love to connect with our users and get them started.
Doesn't sound complicated. Sounds pretty easy indeed. And
Yeah,
can you give some more specific of how the database like that works? How the IDB works in particular,
yeah,
let's say.
yeah, absolutely. So a lot of people, including myself, right, they don't understand how a distributed database works. And basically, the whole concept is to be able to separate storage from compute and having multiple nodes to be able to handle your workloads. Um, so we have multiple nodes within TiDB that automatically distribute the data into specialized data stores for transactional and analytical workloads. Our Smart Optimizer actually provides a consistent, solid performance and will automatically retrieve the data consistently based on the user request. And we can easily scale this platform online. So, without getting into the technical details, it gives you a very powerful, highly scalable, highly available platform with business continuity and security to be able to run your database workloads and this distributed SQL technology. So that's what I would say in simple words. And we can definitely do a follow up, deeper dive if users would love to talk further. They can connect with us, and we can go into more of the technology of how it works. And one thing to say that really makes us different compared to other distributed SQL databases, we are the only open source database technology in the market today that can handle two primary use cases, which is transactional and analytical workloads, all within the same database platform. And we are MySQL compatible. So that is something that we are very proud of, to be able to be in that niche category. And I really feel it helps us stand out and attracts a lot of customers to be
Yeah,
able to look at it.
yeah, it's definitely a big value having this hybrid thing in one place, not without the need of jumping around between different systems just to query the data is a big advantage. I would agree. And since I'm coming from the AdTech industry, and it would be interested for me to hear any real world cases of how companies yeah, implemented distributed databases and how this kind of distributed approach helped them to be more efficient and maybe fasten their growth rapidly.
Absolutely. We have some public referenceable use cases I can share with our viewers today on this show. I think a lot of us know about Walmart. There's probably a Walmart in almost every city in the world, especially here in North America, right? There is a counterpart of Walmart that Walmart owns called Flipkart. It's a very large e-commerce site in Asia, and many billions of people, customers, are using this platform today, Flipkart. And if you go to the website flipkart.com, you can go there and just about purchase almost anything, just like you would be able to on Walmart site. So they have billions of customers, and to be able to handle that workload, it's being managed by TiDB, Titanium Database. They recently just published a blog last week where they shared publicly online in many social media channels to be able to handle 1 million queries per second. And they were able to implement this while saving money to be able on their infrastructure and database licensing costs with Titanium database. Another one is Pinterest. Many people use social media websites like Pinterest to share information and share cool ideas of things that they're doing and pinning them, right? So they make a lot of revenue from AdTech. They have nearly 500 million monthly users, and they need to manage six different data. Originally, they were managing six different databases or so to take on a complicated order of operations, and they had limited functionality of their applications with this older legacy platform. They looked at TiDB to help them eliminate all of six of their solutions that they were using, and they consolidated into one TiDB database cluster platform, and they were able to save over 50% of their hardware costs and decrease latencies up to 90%. That's a huge win.
Hmm.
Yeah. And a
No.
couple of quick ones. Yeah, go ahead.
Yeah, no, I just wanted to say that's really impressive. Like, such a huge reduce from the amount of system that you need to use just to store and query the data. It's like really impressive. Did you want to say something about that
We
as
just,
well?
yeah, no, absolutely. That's really good feedback. And just a couple of more use cases. We have Square. Um, uh, where one of the chief architects explained how their engineering teams were always having to shard. We talked about sharding and managing the sharding methodology to manage the large volume of data. So they were able to go to TiDB and basically virtually eliminate sharding, right? Because our database platform automatically distributes the data. You don't have to worry about sharding it anymore. And then finally, just wanted to add that many large Fortune 500 companies are using TiDB right now in production, and the list keeps growing. So we do have a conference coming up in September. Maybe we can share the link with the users. It's called the HTAP conference coming up here in California, Mountain View at the Computer History Museum. And if people want to learn more about distributed SQL databases, it would be a great place to come to and to learn more about use cases of how customers are using distributed databases like TiDB and other ones as well. You know.
Hmm, I see. Yeah, thank you for the invite. I will definitely put the link to the event in the description as well. And if we are talking about the like current development on the market, and it is definitely the AI, which is everywhere now, and everyone is talking about that. And how do you see the AI and the demand for AI-related software is shaping the database industry?
One thing I will say, the database is at the core of every application, right? Without the data, it's virtually impossible to do any kind of data
Hard,
processing.
hard to argue. Hard
It's the
to
heart,
argue.
yeah. It's definitely, yeah, the heart. So one really cool technology is called generative AI. It's the ability to be able to analyze large volumes of data and to be able to do different things, such as one of them is, um, you know, imagine just taking a use case where you can write something in English, an English question, something in English, and have that question converted into an SQL statement. Imagine just creating your tables, loading your data, and just asking, okay, what are the top selling products in this specific region by this specific month or by this specific year, right? And that's an example of generative AI where we have integrated with Chat GPT, and we call it Chat to Query. And this is available in our serverless cloud tier to be able to do this. Just send English queries to your TiDB database cluster and have the SQL generated for you and run. So this is an awesome example. And then a couple of more is when you work with large volumes of streaming data, the need to be able to compare these results in real time to historical trends is very important. And HA is becoming more valuable for internal applications, and decreasing the latency is much more important. And another important point of generative AI is being able to be more proactive versus reactive, being able to predict behavior and trends based on analyzing the data. So just imagine having real time data coming in and having your generative AI analyze that data on the fly and then help users to be able to make real world decisions to make the right choice, whether they need to do A versus B.
Hmm. Yeah, no, those examples I'm definitely very interesting and impressive. I'm a fan of AI, and I'm always looking around for some new tool that can increase the productivity for me or for the team, and always looking for something new on the market. And it's going on. It's like every day we are getting either new software, either new service based on AI, and I'm a big fan of that, and I'm just looking forward to have more of that. And as we are talking about the evolution of the database industry, we talk about how it evolved during the last couple of decades, and I believe it's time to think about the future. What do you think? How it will look like, and what are the trends you observe now in the market that will shape the industry?
Absolutely. So, one topic I'll be speaking about at our HTAP conference coming up will be serverless technology in the cloud. Many companies are now looking to the cloud to be able to save on capex and have an operational, just go to an operational expense model. And many companies have a cloud initiative, and some don't. Some of them are staying on premise, and some of them are going to the cloud. They have to decide what makes sense for them. But one current trend in the cloud technology is serverless, being able to run your application and database workloads based on your demand, right? Imagine being able to scale compute and storage and memory in real time based on your workload demand. Another one is AI and machine learning. We just talked about artificial intelligence and being able to have generative AI to be able to scan volumes of data to help make decisions for users and business leaders, um, because this is going to be now the future trend. I mean, analyzing the data and then making key decisions is very, very critical. People just don't guess anymore, right? They actually have to look at the data to make future projections. And then another cool trend is quantum computing. It's an emerging technology, and being able to run workloads that users couldn't have even imagined now and solving those really complex problems. Imagine having quantum computing working in conjunction with database technology to work together to help deliver answers in real time very, very quickly. So a lot of our complex problems that we're trying to solve today, such as researching cures to many diseases such as cancer and others, right? We can use quantum computing to be able to help research and fight those things, right, and find cures. And then finally, an ongoing thing that I think companies are looking at all the time is how can we consolidate, how can we standardize, and how can we reduce our total cost of ownership, right? This is an ongoing thing. People are always looking to modernize, to be able to consolidate and standardize, because this is things are always changing and evolving all the time in terms of infrastructure, applications, databases, cloud. To be able to make and simplify that architecture, I think is going to be very key for many business leaders and technology leaders today.
Apparently, it's the bright future ahead of us. AI, quantum computing, probably there would be no database with no AI very soon. And we are at time, unfortunately. And thank you, Nabil, for joining me today. It was very insightful and interesting conversation. Uh, Very glad to have you here on my podcast. And if you have anything to say to the audience, feel free to do it now.
Yeah, I just wanted to thank you for the opportunity. Very nice speaking to you and your audience today. Glad we had an opportunity to speak about database technology and where it's going. Hope to talk to you again in the future. Thank you.
Sure, thank you. I will provide the links to the Nabil's profile and maybe some other links he mentioned about, and the link to his book and to the events he mentioned as well. Okay, thank you so much. Bye.
Thank you.